Okay, so lesson 4 is going to take us into multiplying and dividing radicals. Okay, so it's a little easy. It's a lot easier than adding and subtracting. So let's just jump right into it. So essentially, you can treat it like it's all under the same square root, as long as it has the same we can't multiply cube roots and square roots, but if it's the same, we can just multiply them. Okay, so if we were talking about like expressed in the simplest form, we have the square root of 2 times the square root of 6. I can just rewrite this as the square root of 2 times 6. Right. Another way to do this is I can break this down even more. So the prime numbers for 6 is just going to be 2 times 3. I can pull out a pair of 2's. We're going to be left 2 with 2 square root of 6. That's one way to do it. You could have also gone straight into, well, 2 times 6 is 12. This is version 2. You don't have to write both. You can do whatever is more comfortable for you. Well, I know that this is 4 times 2 and 4 times 3. Well, the square root of 4 is 2, right? So we have 2 square root of 3. Okay, same thing, right? So there's a couple different ways to do this. Don't feel like you have to do it any one particular way. Okay, so when we are multiplying radicals with a coefficient, right? So we can multiply our coefficients and our radicals together. Okay, I am going to leave the coefficients alone until the very end, because I might be able to pull some stuff out when we multiply our radicals. So we have 2 times 10. Then I'm just going to put everything under the same square root. So we have 5 times 30. Okay, all I'm doing is rearranging it, right? Well, I know that I can break down the square root of 30 into 5 times 6, right? So we have, and 6 would be 2 times 3, right? So we can do 2 times 10, and this can be broken down into 5 times 30 would be written as 2 times 3 times 5, right? I'm looking for pairs. I have 5 that I can pull out. So we have 2 times 10 times 5. And then I can't simplify as 2 and 3. So I'm gonna multiply that back together, and we're going to end up with the square root of 6 inside. Well, 2 times 10 is 20, and 20 times 5 is going to be, oh, I'm blanking, sorry. But 10 times 5 is 50. 50 times 2 is 100. So we're going to have 100 square root of 3. So I said 10 times 5 is 50. 50 times 2 is 100. That is our final answer, right? That's our simplest radical form. Okay. Okay, let's take a look at example 2. So now we have some division problems, right? So we can go ahead and do something like this, right? So we only have square roots on the top. So I'm going to go ahead and simplify that first, right? We already know that the square root of 12 is just going to be 2 times the square root of 3. So I'm just going to jump right to that point. That is from the first problem, right up here, divided by 6. And now I can just simplify it, right? So I'm looking for numbers that are something that is divisible, something that 2 and 6 are divisible by. Okay, so I can divide the top by 2 and the bottom by 2. So you're going to end up with the square root of 3, because these are going to just go away, and we're left with 3 on bottom, and we are done with this division problem, right? So sometimes you might have square roots on top and bottom, okay? I will say this. You want to make sure that you do not have a square root on bottom. So say we have something like this. Actually, no, let's do this problem first, and then I'll show you an example like that. Okay, so we have, again, just like we did with multiplication, we can put everything into the same square root. So I'm just going to go ahead and do that, right? So we're going to have 160 divided by 5. Well, 160 divided by 5, where's my calculator? I just had it. Let me pull up a calculator right here. Come on. Come on. All right, so we can do 160 divided by 5 would be 32, right? So this would be like saying the square root of 32. All right, so we're looking for two numbers and multiply together to get 32. So my prime factors for 32, I'm just going to break it down over here. We have 4 times 8, and 8 can be broken down to 4 times 2. Well, there's our pair right there. So we can pull out a 4, and we're going to be left with the square root of 2, right? That is your simplified version when we say the square root of 160 divided by the square root of 5. Okay, so if for some reason you get a square root on bottom, I don't know, let me just double check. I don't know if I talked about this. Okay, for some reason, if you get a square root on bottom, we need to rationalize it. Okay, so we don't want like the square root of x on bottom of like 5. If you get something like this, you just need to multiply by 1, right? Another way to say multiply 1 by 1 is I need to multiply by the square root of 5 times the square root, square root of x times the square root of x. This would simplify. So we'd have 5 square root of x, and then the square root of x times the square root of x just ends up being x, because this would end up being the square root of x squared. These go down to here, and that would end up being the square root of x squared is just x. Okay, so do not leave a square root on the bottom. It's going to mark you wrong for that. Okay, so when we're simplifying this, right, everything's under. So we have 2 giant square roots. Okay, so I'm just going to write the fraction 432 x to the 12th, y to the 4th, and we have 9 x to the 3rd, y to the 4th on bottom. Okay. All right, so let's just see. I don't know if 432 divided by 9, that'd be too easy. Oh, okay, it is too easy. All right, so on top, we're going to end up with 48. We're going to use our power rules. All right, this is still all under the same square root. We have 12 on top and 3 on bottom, right? We can subtract those. We're going to get x to the 9th power. And then we have y to the 4th and y to the 4th. Those are going to cancel out. Okay, so we're stuck here, right? So now we're looking for the square root of, this is another way to think about this is we have 48. This would be like saying 4 times 12. This would be 4 times 3. So we can pull out a 4, and we're going to be left with 3 inside. So we have 4 times the square root of 3. We're going to have some x's too, right? So this is saying we have 9 x's, right? So in other words, we have 1. Let's do it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I have 1, 2, 3, 4 pairs. So I can pull out x to the 4th power, and there's going to be 1 left inside. And that is going to be your simplified version of this problem. Okay. Then down here, all right, so now we're multiplying cube roots. Okay, so we've been doing square roots up until this point, but you might see a question like this. Again, same idea. As long as they're the same, we can put them under the same symbol, right? So I'm just going to do a cube root, one giant one, and we will have, well, 10 times, let's do 10 times 12. I'm going to rearrange it as we go. We have x to the 8th times x to the 4th. Okay, well, this would be like saying I can break this down into my prime factors. So we're going to say 2 times 5 is 10, and 12 can be written as 2 times 2 times 3. And then I would have 1, 2, 3, 4, 5, 6, 7, 8 for this one. We have 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then we have 1, 2, 3, 4 for that one. Okay. So I'm looking for, I have 3 2's that we can pull out because we're looking at cube roots now, right? So this is going to be, we can pull out a 2. Then we're going to be left with, I'm going to go ahead and circle these in blue, okay? So we have a 5 left and a 3 left. Now we're going to look at our variables. I can pull out 1x, 2x, 3x, 4x, okay? So I'm just looking for triplets, right? So I can pull out 4 x's. So I'm going to say x to the 4th power. There's no x's left behind. So in my square root, not my square root, my cube root, I'm going to have 5 times 3, which is just going to be 15. Okay. All right, so that is your last example for lesson 4. Again, if you have any questions, please contact me. send me an email or contact me through Parent Square. Have a good day.